9. So since I have extra time, we'll start looking at beginnings of chapter 9. And in chapter 9, this is all about analysis involving exponentials and logarithmic functions. Exponential and logarithmic functions. And we'll start with the exponentials at first. So what we're going to look at is 9.1, properties of exponentials. Now, we know we have a lot of the various properties of exponents. So this is related to all of our laws of exponents. Let's kind of list them here again. But now we're going to look at functions and function notation involving them. That gets a little more complicated. One thing we know, if we have some base a and raise it to the n, and then multiply times another, the same base raised to the nth power, we have the addition rule. You multiply here, you add up here. We also have the raising to a power rule. A to the n raised to the nth power gives me a to the n times n. In addition, we also have the division rule, a to the n over a to the m. And I subtract the exponents. They cancel each other out. We also have that property that any base a raised to the 0 power is just 1. And then we also have some other rules related to, say, I'll put it, what order do I want to put it here? I'll use that at the end. Okay, so you have a product rule, a times b to the n is a to the n times b to the n. And then we have a over b, quantity to the nth power, a to the n over b to the n. Now over here we have things that a can't be 0, here, a can't be 0. I'll put these disclaimers in. A can't be 0 here, a can't be 0 here, and over here b can't be 0. So we have those things. We don't no division by 0 or taking 0 and raising it to the 0th power. We don't know what that means. 0 to the 0th power doesn't mean anything. We also have a rule for negative exponents. A to the minus n is 1 over a to the plus n. And again, a can't be 0. Or you can turn it around and do 1 over a to the minus n is a to the n. So this one, a can't be 0 if n turns out n is a positive number over here. Over there it doesn't have to be, but here we'll assume that it's positive. But those are laws of exponents. Now, what we'd like to do is apply these to functions, if you will. So let's take a look at some examples on how we're going to now apply those. Instead of just to numbers, we'll now apply them to, exponential functions, if you will. So let's take a look at some examples. So say I give you certain things. Say I say, here's the given information. F of x is, say, 2 to the x, and g of x is 2 to the minus x. And I want you to find the following. So let's take a look at this. Let's take and find, say, f times g. And I'll let you try that. Try that and see. I want you to try these examples. See if you can figure it out, and then we'll go over them. Take a look at g over f. And try the following. G of x reciprocal. I'm going to write it that way instead of as an inverse function. I don't want to confuse you there. And let's try this one. This is a harder one. Let's see if you can work with those. Do those 4 calculations using the appropriate laws and rules there. And if you can simplify this a little bit, not much you can do, but a little bit you can do. This is the way we like to write it in the end. Factored form. We'll do some more of these tomorrow after we finish up the other thing. But this gives us a little chance to spend some time on doing these calculations. Okay, first problem. Anyone want to see how I got 1 for that? So everyone getting 1? Okay, so everyone got 1 for that. That's good. Anyone want to see how I got 2 to the negative 2x? Was that okay? Okay, so let's kind of do that. So I'm going to be using this division rule right here. So I'll put it over here. I'll erase these, and I'll put the rules as I need them over here. And what do I have? So I have my g of x over f of x. So it's e to the negative x over e to the positive x. Well, what? Not e, 2. I'm so used to using e's. Well, natural to use e for me. It's a natural exponent. But what I have the same base, different exponents. So what do? I subtract the lower exponent from the upper exponent. So minus x gives me 2. Minus 1 gives me negative 2x. All that is. So I just rewrote these in that form. You will have to get comfortable doing this. You need to be able to work with these exponential functions in this way. How about 3? Anyone want to see problem 3? Because that's okay. What about problem 4? Anyone want to see how I got 4 that way? Okay, so let's plug it in over here. So what do I have? I want f of x plus h minus f of x over h. Okay. F of x plus h is 2 to the x plus h. Oh, I'm putting e. My natural tendency is to go with the e's, because it's a natural exponential. I'm so used to using e's. The base 2 doesn't come up unless you're in a computer science major. You'll see it quite frequently. Maybe that was a confusion over here. F of x is just minus 2 to the x all over h. Now, when you get to the calculus, you will be doing this. You're going to want to try and simplify this. I can break this down, and I have 2 to the, a plus b is 2 to the a times 2 to the b. That's kind of the reverse of the first rule. We usually start with here and go here, but now we're going in reverse. So I'm going to rewrite that as 2 to the x times 2 to the h minus 2 to the x over h. So I did the reverse of the first rule of exponents. I broke it apart. Why? Because now I notice that I have a common factor of 2 to the x, and I can pull that out front. And what gets left behind? Well, that's 2 to the h, and there's always a factor of 1 there, minus 1, and this is all over h. So that's what I have. My mistake is I put a e instead of a 2. I'm so used to writing e's. I wasn't even thinking. But this is something, the difference quotient and this calculation, you will need to be able to do in the calculus. So that's something, it's an important thing for when you go to the calculus. You will see that. And if you understand this function notation, you'll be okay. So let's take a look at another one. Keep those same ones, and let's put a couple of other ones over here, and we'll kind of end a little bit early today. I don't want to go too far ahead. Now we are off on Wednesday. Everyone knows that's Veterans Day. College is not open for classes. So you have that day off, and very shortly thereafter we have our test is coming up. One day we'll test again. Should have it right here. Yeah, so our test is the 18th. So it's going to be a week from Wednesday is our third test. So it's not this week, but Wednesday of next week. Well, no. Yeah, double check it. Okay, try some of these. I'll make some other ones up over here. Try and find that one and this one. Try those two. Let's see if we can figure out what that is. Number 6 is very similar to number 4. Keep wanting to write E all the time. Does anyone want to see how I did problem number 5? So good, everyone seems to be getting that. What about problem 6? So, take a look at number 6. So here's my g, it's e 2 to the minus x. So let's just do it in parts so you can see. G of x h. Well, we know g of x, I'll put it over here, g of x is 2 to the negative x. Well, so it's 2 to the negative, and for x, I'm now going to put in x plus h. So that's equivalent to 2 to the minus x minus h, which I can rewrite as 2 to the minus x times 2 to the minus h, undoing the rule of exponents. Now, I can rewrite that as a sum of those two. So now when I plug it in over here, I get the following. Very similar to the other one, just looks a little bit different. So now I plug everything in. So I plug this into that, and I get 2 to the minus x times 2 to the minus h. minus g of x, well, g of x is 2 to the negative x, all over h. But again, just as in the previous one, I notice that that's common to both. So I can factor that 2 to the negative x out front. What gets left behind? 2 to the minus h, and there's always that factor of 1 there, minus 1 over h. Notice I'm putting all the h terms together. That's one thing you will do when you get to the calculus. Okay, so that's all that's involved with that. So just applying the rules of exponents to these functions. And there's a number of different things that you can do. Try one more over here. Here's number 7. And let's try g of a negative 3x. Can you find what g to the negative 3x is equal to? We know what our g of x looks like. Tell me g to the negative 3 of x. So you get 2 to the positive 3x. Anybody want to see how I did that? Good. Everyone's starting to get the hang of function notation. Everyone's comfortable with that. That's good. Good. So. Okay, so that's one type of problem we have in this section, applying the rule correctly. Now the other type of problem that you have is, given an expression, can you simplify it using the rules of the exponents? So this is one type, type 1 if you will. And that's solving them this way. And let me kind of give you another type of problem. And maybe I will give you the homework on these, and we can spend all of tomorrow just going over any questions you have on homework. Settle it that way, give you a chance to do this. So here's another type of problem. Now we're given a complicated expression, we're asked to simplify. So simplify using the rules of exponents, or the laws of exponents. So let me give you an expression, say, 3 to the x times 3 to the x minus 1 over 3 to the x minus x squared over 3 to the 2x times 9. So see if you can figure out how to combine that and simplify that into a single term. Let's try that and see how well you can do it. And then I'll show you how to do it. So I want to have a number, and then I want to have just something with the, if you will, either. There's a couple of ways of writing it, I should say, so we'll see how it goes. Now you could write it like this. Sometimes you could write it like this. If you want just one exponent over here. This is a nice, convenient way of writing it. This is okay, but it's still not, you know, as simplified as one would like. Does anyone want to see how I got those results? Okay, so let's see if we can start to simplify these. Well, what I have here, let me start with this first one right here. I'm multiplying here, so what can I do? Same base, I can add the exponent. So that becomes 3 to the x plus x minus 1. I added the exponents. Times now, over here, I'm raising this to a power. So it's 3 to the minus x, and then I multiply. When I raise to a power, I multiply. I get that. All over, I get, this is 3 to the 2x. Now, if I want to, I can actually change that 9, because that's related to a base of 3 as well. This is equal to 3 squared. 3 squared is 9. Put everything in terms of the base 3. I can simply add over here. So up top, continuing on in this fashion, that's 2x minus 1, so it's 3 to the 2x minus 1. Here I'm multiplying, that's times 3 to the minus 2x. All over, I can add those together if I wanted to, 3 to the 2x plus 2. I can just add that because it's the same base. Now I can add the exponents over here. So that becomes 3, 2x minus 1 plus minus 2x. So it's equal to 3. I add the exponents, 2x minus 1 minus 2x, all over 3 to the 2x plus 2. Well, these go out. So in the top, it just gives me 3 to the negative 1, all over 3 to the 2x plus 2. Now, what do? When I divide, I subtract the lower exponent from the upper exponent. So it's 3 to the minus 1, and then I have to subtract the 2x plus 2. So that's equal to 3 to the minus 1 minus 2x minus 2. Well, I can rewrite that as, pull the negative 2x to the front, 3 to the minus 2x, a negative 1, and a negative is a negative 3. To write it as a single, with a single base, that's the preferred way. Now, if I left this as a 3 to the minus 1, that's actually 1/3. 3 squared is 9. So the other possibility, I could, if I wanted to rewrite this to get that, so I could look at this in this fashion and write that as 3 to the minus 2x times 3 to the minus 3. Bring that down, 3 to the minus 2x times 3 to the plus 3. Well, 3 to the plus 3 is just 27. 3 times 3 is 9, times 3 is 27, so you also have this approach. This, however, is kind of preferred, especially if you're going to be solving an equation after that. This usually comes into play when you want to solve equations. So you have two types of problems. One is directly applying the rules, and then the other is using them to take a complicated expression and make it into a single simplified expression. So this is complicated. This, however, is basic, and we can use that to help us solve some problems. Okay, any questions on that? Well, what I'll let you do is try some of the problems on the homework. I'll give you both the applications that we have with the trig functions as well as the starting on these exponential functions. Well, maybe we'll do one more. We have time for that because we haven't got enough time today. Let's try one more. Let's see if you can simplify this on your own now. Try this again. So the same instructions, simplify using the rules of exponents. And try and get it as a single exponent term. So say I have, here's my f of x, and I want to simplify this. So I have 2 e to the 2x minus 1, then 2 to the 1 minus x times e times 2 to the x. So see if you can simplify that all together there. It's a lot easier to write 4e to the 2x than it is to write all that mess. Does anyone want to see how I did that? Okay. What I would do is I have different bases here. The base 2 and I have a base, e. So I might separate them out accordingly to their bases. So let me put the 2's together. That's really 2 to the first power. So what do I have? Is I have a 2 to the first times 2 to the 1 minus x, and then I can move this 2 to the x. I put all those bases of 2 together. And then I'll put all the e bases together as well. So here to the e to the 2x minus 1, and that's e to the first power. I just don't write the exponent, but there is a 1 there. Okay, so I'm multiplying here, so what do I do up top? I simply add everything up top. When you multiply, you add. So 2 to the 1 plus 1 minus x plus x. So I'm adding all those exponents. Same thing over here, times e to the 2x minus 1 plus 1. Well, notice what happens here. The x's go out, so I get 2 squared e. The 1 and the minus 1 goes out. E to the 2x, well, 2 squared is just 4, so it's 4 e to the 2x. So just using those rules of exponents to rewrite your various functions in a simplified form. We expand out the exponential. So using those rules of exponents sort of in reverse. So here you might want to expand exponential expressions. It's good practice. More often than not, however, you contract them, but sometimes you will turn around and look at expanding them. But most of it just goes the other direction. Okay, so we'll take here's one simple example. Yes, Ashley, have a question?
I'm sorry, I'm talking so much today. Do you have like source for like more practice on this? Be set like something online where they have answers so you could double check your work. Do you know of anything offhand?
Not offhand. Yeah, this is usually we don't do as much as of this, but it's like anything in math. We show you how to do it one way, and then we show you how to do it the other. That's how you learn something. Do it in both directions. So usually you take a complicated expression and you simplify it. And not as often do you take a simplified expression and expand it out and make it more complicated. But we will see that more in the logarithm. That is where it is more common in logarithms, which is coming up in the next section. Well, I'll put a few problems over here, and we'll spend the time going through this to give you some practice here. And I'll put some up on the board for you can try. So let's take a look at some examples. We'll do the one in the textbook, and then we'll take some others as well. So here's f of x, I'll make some up off the top of my head, e to the 5x minus 4. Now I'd like to expand this all out to just having e to the x in the argument. First thing I can do is That's e to the a minus b, so I can write it as e to the 5x over e to the 4, right? Because that's essentially what, or if you wanted to, let's expand it out. If you don't see that directly, let me put it this way. Students don't see it right away, because I can write that as e to the negative 4. I'll do it in 2 steps rather than 1. There is the division rule in exponents, so you can do it in 1 step. Then that's a negative exponent, so let's move that down and make it a positive exponent. Now if I want to write this with just an e to the x in the argument, then I can use the second rule in reverse, which says, a to the b raised to the c power, or a to the n raised to the m power. I can bring it out as a power. So I can write that as e to the x raised to the 5th power. That's underdoing this relation for the rules of exponents. So this is now where I just have an e to the x in the argument. Now if I wanted to, I could even write that as e to the 1 to the 4th power, if you wanted to. But just giving you a little bit of practice of kind of expanding these out. Okay, let's try another one. Say, for example, I have f of x is 3 to the 3 minus 2x. Kind of a simple one. And I want to expand this out. Well, first thing I'll do is I can rewrite that as 3 cubed times 3 to the minus 2x. Okay. Then I can, negative exponent, I can move that down. So I get 3 cubed, 3 to the plus 2x. I can do 3 cubed. I might as well. That's 27. And I can write this as 3 to the x squared. So these two are equivalent, meaning you may be given this initially, can you undo it and get back to that? So we go both directions over here. Let me give you a couple of these to try. So this will be practice here and now, and then there's a few more on the homework that you can try as well too. Make this a little bit different, see if I can get you over here. Try that one. All right. I'll just throw in another quick one there and see if you can kind of figure what that one looks like. I'm making them up off the top of my head, so I'm thinking through them. Okay, that should be enough to give us some additional practice. Okay, so there's 4 problems to look at. Now I want to see how I did the problem 1, the first one there. Okay, so let's kind of go through that step by step. I'll get rid of this. You have it written down, and I know what the answer is. So what I would do over here is I turn around and this is e to the a. I could do it minus b. Well, let's just do it in 2 steps. I can write it this way. So it's 4 to the 3x times 4 to the negative 1/2. That's a negative 1/2, so that comes down. I get 4 to the 3x over 4 to the positive 1/2. But what is this 1/2? Well, if I can rewrite this as 4 to the x cubed, and 4 to the 1/2 is the square root of 4, which is just 2, so I get 4 to the x quantity cubed, and I have square root of 4 is just 2. So that's one way of writing it, just with 4 to the x power. Because now I could do it backwards if I wanted to. When I raise to a power, I multiply the exponents. Well, that too I can write as a square root of 4, which is 4 to the 1/2, and then I can bring that 4 to the 1/2 up, same base, and then I can add these two together and become subtraction. Okay, anyone want to see how I did number 2 over here? Okay, so let me get rid of 1 over here, so it gives me some space to write instead of being cramped over there. So I'm going to rewrite it in this way. E to the 2x, I'm going to write it with a minus the natural log of x. Negative exponent, that can come down. Well, e to the 2x, I can write as e to the x quantity squared, my rule of exponent. But remember, these are inverse functions of each other. I'm now using the inverse property. So e to the natural log cancels out to just gives me x. So that's what I get for that. And that's essentially what I have right here. Okay, so then let's see problem number 3 worked. Okay, so let's kind of do the same sort of process. So I have my f of x. I'm going to write it as 2 to the x over 2 and minus, or excuse me, 2 to the minus the log in the base 2 of 3x. Negative exponent, so I can bring that down and make it a positive exponent. 2 to the x over 2 over 2 to the positive log in the base 2 of 3x. I can bring this out as a power if I want. I can do it in 2 steps. I can write that as 2 to the x times 1/2. Notice what happens. 2 log in the base 2. They're inverses of each other, so they cancel each out to just give the arguments. That's where the 3x comes from, right over here. Now this I can bring out and write that as 2 to the x raising to the 1/2 power over 3 times x. Well, the 1/2 exponent is equivalent to the square root. So that's the square root of 2 to the x over 3x. Okay. Now this one shouldn't be as bad. Anyone want to see that one? Does that make sense? I'd be happy to show it. If you're not really sure, say yes. I'm not going to look. So, okay. Let's see what we're going to do. This is I put one that was less complicated than the others in there. So I have my, a base to a power with a sum. So I can have my f of x is equal to 3 to the 3x times 3 to the second. So I'm undoing the first rule of exponents. Well, 3 to the second, that 3 squared is 9, so I can move that to the front, times 3 to the 3x. Well, I can write that as 9 times 3 to the x quantity cubed. That's I'm undoing essentially my second rule of exponents about raising to a power. So that's written now just with 3 to the x and some other algebraic or arithmetic operations there.